So today I'll be talking about the Cassini-Huygens Space Mission, and this video will be the part 1 in a short series, and in the future I'll make the part 2 of this series. So in this video I'll be talking about why the Cassini-Huygens Space Mission was developed and how it works. Okay, so the first telescopic observation of Saturn was conducted by Galileo Galilei. However, when he looked at Saturn through his rather crude telescope, he saw 2 moons instead of rings around Saturn. And what mystified him was that after some time, the 2 moons had disappeared, and then after some time, they came back again. And Huygens solved this mystery in 1659 by concluding that it was not the moons of Saturn, but rather the rings of Saturn that Galileo had been seeing. And Huygens also discovered Saturn's biggest moon, Titan. Okay, so then, during the 1670s and 1680s, Giovanni Domenico Cassini discovered 4 new moons. Those were Iapetus, Dione, Rhea, and Thetis. Okay, then in 1973, the Pioneer 11 was sent to explore Saturn, and the Pioneer 11 was the first probe to visit Saturn. Then after that, the Voyagers came. And the Voyagers took detailed pictures of Saturn, more detailed pictures than any probes had taken before. And a fun fact is, the Voyager 2 was actually launched before the Voyager 1. And then, finally, the Cassini-Huygens spacecraft was launched in 1997. Okay, so now you probably know why the Cassini-Huygens spacecraft was named the Cassini-Huygens spacecraft. The Cassini-Huygens spacecraft was named after Cassini and Huygens. Okay, and the Cassini-Huygens spacecraft consisted of the Cassini spacecraft and the Huygens space probe. And the Huygens space probe is also found over here. You can see it over here, this yellow thing. And the Cassini spacecraft made by NASA would orbit Saturn and observe its rings and moons. The Huygens space probe, which was made by the ESA, which is the European Space Agency, would land on Titan and give us a new understanding of the moon. So I mean, the reason why the Cassini spacecraft was made was because the Voyagers had used rather old cameras, meaning that their pictures had less detail than the cameras in the 1990s. This would allow Cassini to take more detailed pictures. And the Cassini spacecraft also contained more superior instruments, meaning that it could take more finer observations. Okay, so now the USA and Europe had both been interested in making a spacecraft a spacecraft and a space probe that would observe Saturn. However, NASA wanted to make this a solo project, which means that NASA wanted to do this all by itself. However, after second thoughts, NASA actual collaboration with the ESA in the project. NASA wanted to strengthen the bonds between NASA and the ESA, and the ESA had been moving closer to the Soviet Union as it was going to go and collaborate with the Soviet Union. So it was not just the USA and ESA who had participated in the production of the Cassini spacecraft and the Huygens space probe. Also, Italy, the Italian Space Agency, had participated, and many more countries have participated. Okay, so now let's talk about how the Cassini spacecraft works. So over here we have the engines. Those are the ones that are actually propelling the spacecraft. And the Cassini spacecraft is powered by the heat generated by the decay of plutonium, which is a very, very strong element. And then the next part is the Huygens space probe. The Huygens space probe, as we discussed, will land on Titan and observe more about Titan. And then we have the radar instrument. The radar instrument works very simply. Here, let's explain. So the radar instrument will send some radio waves to Saturn, and then they will bounce off, and then they will land on the radar. And by observing the time and where exactly they hit on the radar, the Cassini spacecraft can understand about the landscape of where it hit the radio wave. So this was mostly important with discovering on Titan, because Titan had a very murky atmosphere, which meant that it was very hard to see through it. So one image of Titan is over here. So this is an image of Titan that was taken by the radar. So you can see that we can very clearly see the landscape, this very mountainous place. Okay, so next part is the magnetometer. The magnetometer is important in detecting the magnetic fields of a planet, or in this case, Saturn. Then we have the cosmic dust analyzer, and what it does is basically when dust will come towards it, and the cosmic dust analyzer will figure out the composition of the dust and other details about the dust. Then we have the imaging science subsystem. So this is the camera. So if you've been wondering where exactly the cameras of the Cassini spacecraft is, then that's the cameras. So these are basically digital cameras, and however, the cameras are probably not as good as the camera you're using right now, because these cameras, so the average digital camera right now in 2021 uses around 20 megapixels. However, this camera only used 1 megapixel. Okay, so this camera, however, was a little bit more detailed, because it could not only take the pictures with visible light, but also with ultraviolet light and infrared light. Okay, so that's it for this video, and you can watch my Mars Pathfinder over here and our rockets video over here, and just remember to subscribe and stay tuned. Bye!